Hi. So now that we know how to calculate experimental probability, let's take a look into calculating the experimental probability of compound events. So a compound event is an event that includes two or more simple events, such as flipping a coin and rolling a number cube. A compound event can include events that are dependent on each other or are independent. Events are independent if the occurrence of one event does not affect the probability of the other, such as flipping a coin and rolling a die. Flipping a coin does not depend on the number die. Though if you're going to do an experiment with stopping speed of a car, if it's sunny, then the stopping distance of a car is going to be less than if it was raining. So whether it's raining or sunny would affect the stopping distance. So that would be an example of a dependent case. In this case, they're giving you a case that's independent. Flipping the coin and rolling a number cube. So if we take a look at that, we have flipping a coin, you can either get a heads or a tails. Those are the only two possible outcomes with flipping a coin. With rolling a number cube, we can get a 1, a 2, a 3, a 4, a 5, or a 6. So this is our A, this is our B. They're telling you for C to complete the list for all possible outcomes for flipping a coin and rolling a number cube. So what they're trying to show you is that if you flip a coin and get heads, I'm just going to use H for heads, then you can flip a heads and roll a 1. You can flip a heads and roll a 2. You can flip a heads and roll a 3. You can flip a heads and roll a 4. You can flip a heads and roll a 5. You can flip a heads and roll a 6. You can flip tails and roll a 1. You can flip tails and roll a 2. You can flip tails and roll a 3. You can flip tails and roll a 4. You can flip a tails and roll a 5. Or you can flip a tails and roll a 6. So if we count, there are 2 events here. There are 6 events here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 times 6 gives us 12. So there are 12 possible outcomes. D is telling you flip a coin and roll a number cube 50 times. Use tally marks to record your results. So then they're asking, based on your data, which compound event had the greatest experimental probability, and what was it? What about the least experimental probability? So really what's happening here is they're just showing you with the experimental probability. If you want to try to do this one at home, you can. Though I was more showing the idea of the compound event. So I'm going to go into the first example that they actually show us in the book. So here's the first example that they actually go through in the book of calculating experimental probability of a compound event. So they're telling us a food trailer serves chicken and records the order size and sides on their orders, as shown in the table. They're asking, what is the experimental probability that the next order is for 3 pieces with coleslaw? So what we have to do is, if we have in the chart, which is fine, we see that it's going to end up being, with coleslaw, 55 is going to be our favorable outcome, but we have to add up everything in the table to find out our total outcomes. Because remember, our probability is your favorable outcome what outcome that you want to happen over the total amount of outcomes. So in this case, they're showing you, find the total number of trials. When they add up all the numbers in our chart, they get 330. That means that they sampled 330 people to figure out what they ordered. Out of those 330 people, 55 people ordered a 3-piece chicken with coleslaw. So they did their favorable over total, 55 over 330, and then simplified it. So if we take a look at this question right here, they're giving us our chart. We have to add all this up to figure out our total amount of trials. They're asking, drink sales for an afternoon at the school carnival were recorded in the table. What is the experimental probability that the next drink is a small Coca-Cola? So a small Coca-Cola, Cocoa, they're talking about this 60 right over here. But we have to add up all our numbers to figure out our total amount of trials. So we're going to add up, and this is for 1. We're adding up 77, 98, 60, 68, 45, and 52. If we add that up, we get 7 plus 8 is 15, plus 0 is still 15, plus 8 is going to be 23, 28, that's going to end up being 30, drop our 0, carry the 3, 3 plus 7 is going to give us 10, 19, 25, 31, 35, 40. Drop a 0, add the 4. That means that 400 drinks were sold. So we have our 60 for our small cocoa. And then we have our 400, which is our total sales. So that's going to be our experimental probability, but we need to simplify that. So we can take our 60 over 400, knock out the zeros, that's going to be 6 over 40. They're both even, so if we want to divide by 2, we can divide by 2. That's going to end up getting us 3 over 20. And we can't reduce that any further. So that's going to be our answer for what is the experimental probability the next drink is a small cocoa. So here they're telling you to use simulations to make a prediction. You can use a simulation or model of an experiment to find the experimental probability of compound events. So we've done a little bit of practice with making predictions. Now we're going to do predictions with compound events. So at a street intersection, a vehicle is classified either as a car or a truck. And it can turn left, turn right, or go straight. About an equal number of cars and trucks go through the intersection and turn in each direction. Use a simulation to find the experimental probability that the next vehicle will be a car that turns right. So since it's about equal, whether it's a car or a truck, they're telling you, use a coin toss to model the two trucks, the two vehicle types. They're saying let heads be a car and tails be a truck. So that's for our car versus truck. And they're saying use a spinner divided into 3 equal sections to represent the 3 directions shown. So if we have left, right, straight, we then need to find sample space for our compound event. So we can either have a car that goes left, a car that goes right, or a car that goes straight. We can have a truck that goes left, a truck that goes right, or a truck that goes straight. So there are 6 possible outcomes. So now then we need to perform the simulation. They're telling you that they spun the spinner and flipped the coin 50 times. And this was their outcome. They want you to find the experimental probability that the car turns right. So they're doing their frequency that the car turns right, which is 6, over their 50 times. If we add all of this up, we're going to get 50. They simplify it to give us 3 over 25. So they're saying, based on the simulation, the experimental probability is 3/25 that the next vehicle will be a car that turns right. So basically exactly what we've been talking about. So here they're giving us another problem. They're telling us a jeweler sells 2 necklaces made in 3 sizes and 2 different metals. Use the data to form a simulation to find the experimental probability that the next necklace sold is a 20-inch gold necklace. So they already did the experiment for us. We have to add up all of our numbers, figure out how much is in here. And they're saying a 20-inch gold necklace, that's going to be 12. So we're going to have to do 12 divided by what we figure out in here. So this is number 3. So for 3, we have 12 plus 16 plus 5 plus 22 plus 8 plus 12. We have to add all that up. We have 12 plus 16 is going to give us 28. 28 plus 5 is going to end up giving us 33. 33 plus 22 is 55. 55 plus 8 is going to end up giving us 63. 63 plus 12 is going to give us 75. So we're going to have to do our 20-inch gold, which is 12, over our total, which is 75. We can divide both our top and bottom by 3. And that's going to reduce to 4 over 25. That's going to be our answer. So I want you guys to work on these problems right here on page 385. If you have any questions, I'm going to be doing a Google Meet at 10. So you can ask your questions in the Google Meet, or you can post on Google Classroom. If you have any questions, please make sure you ask. Thank you.